Okay, so I wanted to talk a little bit more about transformations. So, we're dealing with parent functions that look like something like this. Now, there's a multitude of other parent functions with different bases. It's just we're using these two because they're easy to deal with and they don't get, if you have larger numbers, the functions grow rapidly, and most exponential functions have a base of e, which is between 2 and 3, but e is a little harder to deal with, so we're going to just deal with 2 to the x and 3 to the x. And we know how to plot those functions by just picking x values. Now for 2, we can go all the way to 3. So here we have 2 to the x, so we're going to have, this will be 1/4, this will be 1/2, this will be 1, this will be 2, 4, 8. So these are easy. 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 times 2, 2 times 2 times 2 is 8. And then you just take the reciprocals of these to get the ones at the negative numbers. Likewise over here, you're going to have a similar kind of thing. We'll start here at -2, -1, 0, 1, and 2. Let's start at 0. 3 to the 0 power is 1. 3 to the first power is 3. 3 to the second power, 3 times 3 is 9. And then we could do 1/3 and 1/9 for the other side. So we can plot those parent functions if we want to. Now, what we're going to talk about here is some transformations. So the form of the transformed function, let's first talk about just x and y shifts. So we had 2 to the x minus h plus k. This would be an x shift of plus h and a y shift of plus k. So it's just like previous problems, but in this case, the x shift is in the exponent. Now we're going to do these shifts by shifting the axes where we plot these points relative to. Then you got the reflections. So if you have the negative sign out in front, then just like normal, this is the x-axis reflection. And if you have the negative in the exponent, then you have the y-axis reflection. So let's think about what those are. So I'm just going to kind of draw a sketch here. I'm not going to plot all these points, but 2 to the x is going to look something like this. So when you do an x-axis reflection, what happens is it goes like that. So you're reflecting things across the x-axis. Then when you have the negative in the exponent, again, you have your parent function looks something like that. The y-axis reflection looks something like that. So we switch across the y-axis. So again, nothing unusual. Once we know the parent function, the reflection should be fairly straightforward. So what we're going to do is we're just going to do a couple of problems just demonstrating this. So let's say we have g of x equals 2 to the x plus 1 minus 4. So we've got both x and y shifts. So our x shift, because we have x minus h and we have plus 1, we're going to have a negative 1 shift in the x direction. And then the number that's fact on the end here is the y shift, which is -4. So let us get a piece of graph paper. So we're going to plot the parent function. So the parent function in this case is just 2 to the x. So 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, and then you take the reciprocals of these, half, a fourth, and 8. So this is going to be my parent function, f of x. So to or to show the shifts, we're going to move the x, we're going to shift in the x direction -1, which means we're going to shift the y-axis. And we're going to shift in the y direction -4, so we're going to shift the x-axis 1, 2, 3, 4. So now we've got this, and what you do on your paper is you just do a very light axis. You do your main axis would be dark, and then you put it in pencil. And then all we do is we just plot the points relative to that new, not as bright axis. So you can go back to your parent function. So, relative to the new origin, we're going to go up 1. Then we're going to shift right 1 unit, up 2. Then we go 3, 1, 2, 3, up 4. Actually, we go 2 relative to the original axis, 1, 2. So we're going to go relative to the new axis, 1, 2, and then up 4. And then 3, 1, 2, 3, and up 8. So we go here, 1, 2, 3, and up 8. So that's 4, 5, 6, 7, 8. And then we do the reciprocals as we go towards the x-axis. So now we can draw this like that, and that would be g of x, the transformed function. Okay, let's do one more where we're just doing the x and y transformations. And let's use 3 instead. So we'll do 3 to the x minus 2 plus 1. So our parent function is 3 to the x, and our x shift is plus 2, and our y shift is plus 1. And let's get a piece of graph paper. So let's plot our parent function. So our parent function is relative to our normal coordinate axis. So we have 3 to the 0, 3 to the first, 3 to the second. Then we'll go the reciprocals, 1/3, 1/9, and there's our parent function. Now to do the transformation, we do an x shift of plus 2, so we're going to shift the x-axis plus 2, I mean not the x-axis, the y-axis, and we're going to shift the x-axis plus 1. So that's my new, origin. and we're going to do everything relative to that new origin. So before we went from the old origin up 1, so we're going to go from the new origin up 1. We went over 1 up 3, so we're going to go over 1 up 3. And then we'll go over 2 up 9. And then we'll take the reciprocals of those relative to this new axis. So we'll go 1/3, 1/9, and there is the transformed function. Okay, let's look at, okay, now we're going to do a x-axis reflection. So x-axis reflections are designated by the negative in front of the base. Now we're not raising -2 to the x plus 1 power. We're actually raising 2 to the x plus 1 power, and then we're taking the additive inverse of that. But because this would be in contrast to this, which is not really an exponential function that we've been looking at, because you'd end up alternating back and forth. So this really would not make much sense. So that's why we don't have to necessarily put the parentheses here to be clear, but we could put it there to be more clear. Okay, so what this means is x-axis, which means positive y values become negative y values. And as far as the transformation of the function in the x and y directions, we do the same thing as we've done before. So this is going to have an x shift of -1 because we have x plus 1 up here, and we have a y shift, which is just this number here. So that's -2, and we have an x-axis reflection. So let's see how we plot this. So we're going to take the, well, first we're going to do the parent function, and the parent function is 2 to the x. So 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, and then we take the reciprocals of those, so you get a half, a fourth, and an eighth. So that's your parent function. Now, to do the transformation, the x-axis reflection actually goes around this way. So it goes down instead of up. But we're going to take our axes and we're going to shift those. So we're going to do the x-axis shift, which means moving the y-axis -1 unit, and we'll move the x-axis, which is y equals 0, down 2. So that's our new origin. But instead of going up based upon this thing, we're going to go down. That's what the x-axis reflection does. So starting here, this new axis, normally we would have gone over, well, first thing we would have done is just gone up 1, like we did here. X equals 0, y equals 1. So here we'll go x equals 0, y equals -1. So these 2 points correspond. Then we go over 1, up 2, because it's the base of 2. So we go over 1, down 2, instead of up 2. Okay. The third point is to go over, from the original origin, we go over 1, 2. 2 squared is 4. Did I do that right? No, actually I plotted that point wrong. So that wasn't there. Okay, back to the one we're doing. So we go over 2, down 4. 1, 2, 3, 4. And the other one's probably going to be, well, no, it won't be quite off the screen. So we go over 3. 2 cubed is 8. 1, 2, 3, 4, 5, 6, 7, 8. So that will go there. And then we do the reciprocals. So here we have 1/2, 1/4, 1/8, and then we approach that line from the other direction. So that's how you handle x-axis or y-axis reflections. Okay, I'm trying to decide whether to do another one of those. No, I don't think so. Okay, the next one is we're going to do a y-axis reflection. So let's do g of x equals 3 to the negative x plus 2 plus 4. So the negative being up here gives us a y-axis reflection. So remember, y-axis, we take it like this and then we flip it around the y-axis like that. But like we do with all y-axis reflections, and if you don't do this on the test, you're going to get penalized heavily. You factor out the negative sign. If you don't factor out the negative sign, you're not going to get much credit at all. Okay, so now that we have it in this form, we can do our transformation. So we're going to have an x shift of plus 2, a y shift of plus 4, and we're going to have a y-axis reflection. So those are the three transformations that we're going to have. Okay, so let's do our parent function. Parent function is f of x equals 3 to the x. So let's go over here and do the parent function. So we're going to start the origin, go up to 1, 3 to the 0 power, 3 to the first power, 3 to the second power, then we do the reciprocals, 3 to the negative 1, which is 1/3, 3 to the negative 2, which is 1/9. It's close enough. Okay, so there's our parent function. So our transfer function is going to have the same relative location of the points, except they may be flipped. Okay, so we're going to do the axes first. So we're going to have x shift of plus 2. That means the y-axis gets shift plus 2. And we have a y shift of plus 4, which means we're going to move the x-axis plus 4. So there's our new origin we're going to base everything upon. Now here we went, well, we still have the same orientation. It still goes up. So y-axis means we flip left to right to left. So here we went over 1. 3 to the 1 is 3. So we go the opposite direction. So we do 3, we go negative 1 up 3 instead of plus 1 up 3. The next one's going to be off the scale. Then we'll take the reciprocal, so we'll get, instead of 3 going left 1, going up 3, we'll go right, we'll do 1/3. Then we'll do 1/9. So that will be what this one looks like. So this is a y-axis reflection. And the next one we're going to do is a y and x-axis reflection. So we're going to have g of x equals negative 2 to the negative x plus 3 plus 3. Again, with y-axis reflections, we always factor out a negative sign. So it fits the form that we've seen before in terms of knowing the proper x and y shifts, well, the proper x shift. So looking at it in this form, we'd say the x shift is plus 3, because we have x minus 3. The y shift is plus 3. The negative in the exponent means y-axis reflection. And the negative in front means x-axis reflection. Okay, now let's get a piece of graph paper. So our parent function is going to be 2 to the x. So again, we come over to our graph. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 2 times 2, which is 4. 2 cubed is 8. And then we do the reciprocals. So reciprocal of 2 is a half. Reciprocal of 4 is a fourth. Reciprocal of 8 is an eighth. So this is our parent function, like that. Now, as far as our transformer function, we have to shift the axes 3 units to the x, so that moves the y-axis. The y-shift is 3 units, so the x-axis goes up. So there's our new axis. So what we're going to do, normally we would go over, we put a dot here, just like we put a dot here. We go to the origin up one. Well, because of the y-axis or x-axis reflection, this point, and this point are corresponding to each other. They go down. The next point, we would go to the left, to the right one, and up 2 to the first power. So here we're going to go to the left, because here we went to the right. Here we went up 2. Now we're going to go down 2. So we're going to over 1, down 2. So that these two correspond to each other. Here we went over 2, up 4, 2 squared. So here we're going to go to the left 2 and down 1, 2, 3, 4. Let's do one more because we're doing 2 as the parent function. So here we went 1, 2, 3. 2 cubed is 8. So here we're going to go negative 3, 1, 2, 3, and down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we can do the reciprocals on the other side. So here we had 2, then we go half. Here we went 4, so we go fourth. Here we have 8, so we go an eighth. And then it will look something like that. So that is our transformed function. So this is our g of x, and this is our f of x. Okay, you'll get some more practice and homework of all those particular variations. I'm going to do one more, which is just to show you how stretching works. Now, I'm not going to add this on. I'm going to talk about it separately. But let's say we have the parent function 2 to the x. Now, if you multiply by 3, so this is going to, normally this would give you a vertical stretch when you put the number out. So if we do that, you would still do your parent function and then kind of scale it off of that. So let's do, now because of this multiplier, it's going to increase even more quickly than it normally does. So it may run out of space pretty quickly, but you know, our parent function, call it g of x this time, 2 to the x. 2 to the 0 is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third power is 8. And then do the reciprocals, half, a fourth, and an eighth. Okay, so those are the points. Now all this is going to do is stretch it vertically. So what we have is, you know, if we think about it, if you had x equals 0, instead of 2 to the 0, which is 1, you'd have 3. So this gets, instead of 1, you just multiply this y value times 3. 1, 2, 3. So there's that. This one is 2. 2 times 3 is did I do that right? No, I did that wrong. I counted 3 extra. This is 1. It should be 3, so it's 1, 2, 3. There we go. Here we have 2, so instead of 2, 2 times 3 is 6, so you go 2, 4, 6. The next one is going to be 3 times 4, which is 12, which is off the screen. Here we have we have a half, so a half times 3 is 3 halves. Here we have a fourth. Fourth times 3 is 3/4. And here we have an eighth, so an eighth times 3 is going to be 3/8. So you can see what happens is we just increase more quickly by a factor of 3. So that's a vertical stretch. Now let's look at the horizontal situation. So there we would have something like, let's use g of x again. So you'd have 2 to the 2x. So we have the multiplier is in the exponent. So what does that do? Well, what it does is it makes things happen twice as quickly, but one thing doesn't change is this point, this anchor point. I'll explain that in just a second. So let me add a page. So vertical stretch and a horizontal shrink are not exactly the same here. So again, the parent function is 2 to the x. So let's draw that. So 2 to the 0 is 1. 2 to the first power is 2. 2 to the second power is 4. 1, 2, 3, 4. 2 to the third power is 8. A half, a quarter, an eighth. So there's my parent function. Now, what you can see is that, let's say when x equals 0, 2x also equals to 0. So we're still going to have this same point here. That point doesn't change. But what happens is these other ones change more quickly. So if we, let's say, we let x equal 2, well, let's say we let x equal 1, then 2x is equal to 2, so g of 1, this function is going to be 2 squared, which is 4. So instead of going up to 2, we go up to 4. If we did the next one, if we did x equals 2, we'd have 2 times 2, which is 4. 2 to the 4th power is 16, so this one here is already off the screen. And then if you look at some negative numbers, so let's look at, let's say x equals -1, 2x is equal to -2, and if we take 2 to the -2 power, it's equal to a fourth. So here, when we went left 1, we went down to a half, but now we're going to go down to a quarter. And then this one, instead of going down to a quarter, we'll go down to a eighth. And so this follows the x-axis longer before it turns up, but then when it turns up, it goes like crazy. So this red one is the parent function. Actually, using this as f of x. Oh, yeah, g of x. That would be f of x, and then the blue one here would be f of g of x. It'd be would be g of x. So the black one is this one. I got the colors mixed up. So g of x is the blue. Did I get that right? No, it's the other way around. Let me erase those things. Okay. So the parent function is 2 to the x, over 1, up 2, over 2, up 4. So this one is 2 to the x, but this one that gets, it is stretched vertically and it's also crunched horizontally, but the thing is that this point here at x equals 0 doesn't change between the two functions. This would be 2 to the 2x. So it's a little more complicated, but that's basically how that works.